Hello everyone, here's our Big Data Analytics final project, the Citibank System Data Analysis. Let's start with, what is Citibank? Citibank is the first bank sharing system in New York City, and it starts its operation in May 27, 2013. It has two payment methods, subscribers and temporary customers. And currently, it has over 300 stations located in Manhattan and Brooklyn and will extend to Queens in 2015. And it currently has over 6,000 bikes and over 34,000 steady ridership. And here is some pictures of the city bike stations. Being in touch with this outstanding system, we may have some questions about the behaviors and the stations, so that's why we give this evaluation of the system data of Citibike. The dataset is provided by the company on their website, and it has the trip duration in seconds, the start date and time, stop date and time, the start station ID, name, and the latitude and longitude. Also, the stop station ID, stop station name, latitude, and longitude, and the bike ID, the user type, the birth year of the user, and the gender of the user. Now we use peak Latin statement to process the data. Peak Latin statement is a relation-to-relation operator, and we write a script to process the dataset. And here's our developed environment, peak version 12, Java 1.7, and local mode. So first, we group the data and apply Manhattan distance and manipulate with other statistics numbers. So this is our script, load data, group records, calculate, and stored output. And here's a simple demo of this part of code. So we can see the output from last time is still remain. So first we need to remove the output. Then run the pig script. So you can see the execution is successfully over. So we go to the directory of output and use vim to check the output. So here's a table of the result. It starts from September 2013 and end up in August 2014. And you can see the chart. There's a obviously curve. So what do these numbers mean? The total distance traveled in this year can make us travel from Earth to Moon 42 times. The reduction in emission of carbon dioxide is about 4,000 metric tons, which need 4 times the amount of the trees in Central Park to absorb them. And the total fuel cost saving is about $1 million, which can buy 12 supercars. And the total calorie burned is about 600,000, equal to a lot of Big Macs. So as the summary, we can see the usage of Citibank is very high, and it brings a lot of profit and benefit to New York City, and the distribution of user and usage has specific characteristics.
The most of users finish the trip in 30 minutes, while there are still a few people ride more than 2 hours. And the average trip duration from 16 to 36 varies little, and the average trip duration is 800. The average age of rider is 38.2, and standard deviation is 11. Most of users are under 75, and people around 25 to 45 contribute most revenue to Citibank systems. The most popular stations are around the Central Park and downtown. There's a huge difference between those popular stations and unpopular stations. Those are most popular ones. From the perspective of months, Citibank is used most frequently during May to October, and the average borrow time is 1 million. Subscribers contribute to the most of the records. During a week, subscriber borrows most bike at weekdays, while customers, mostly are short-term borrowers, are active during weekends. In one day, the peak time for subscriber is 8 a.m., 5 p.m., and 6 p.m., while the peak time for customer is 4 p.m.
Hi, we are going to show how to use the K-mean to do the application on our New York City bike. So at first, in the K-mean algorithm, it will randomly choose some the clustering points to be our clustering centers, and then it will calculate the minimum distance from the dataset points to the clustering centers, and then we will use these new cluster points to get a new cluster centers, and we keep clustering. So finally, we will get our ultimate, the k-mean clustering, and it is a little similar to the classification. So in our case, in our city bike case, in from our data set, we have the latitude and the longitude of our stations. So it is our data set, and we input this data into our MATLAB function, the k-mean function, and we will set up the clustering numbers. And I set it up to be the 5, so we will get the 5 groups after we use the clustering. And after that, we will get the index back from our function. It will be the 1 to 5, and that means the index is corresponding to the dataset points. So finally, we can, according to that index, we can plot the clusters. So every time when we run the algorithm, it will be slightly different because it randomly chooses the center. So it is our Manhattan maps, and it includes the downtown and the Brooklyn. It is the places where our city bikes are. Okay, now we are going to demonstrate how to use our code, and we had already imported our data points into the MATLAB, and the result is the station points, and the red point is our cluster 1 and cluster 2, 3, 4, 5 in order, and finally we will get the cluster 5 in the picture with the different colors as we can see in the picture. So we can keep look at the next and we can at first we can look at the left and up corner of the diagram. The blue points are the stations where our city bike are. So and we can move to the right, and we can see the red points. The red points means they are in the same cluster, so it means the cluster 1. So we can get our cluster 1, or get our cluster 2, and get our cluster 3, and finally we could get all of our cluster 5 cluster, and I use the different colors to separate them to let us know the difference. And in this result, we can roughly induce, or we can guess the people who live in that corresponding region will probably use the city bike station in that cluster. So maybe I think it's a kind of a useful information for us to roughly to categorize the people into 5 groups. So, and we also try to attempt to cluster the traveling people and the residents by the different user type, the subscriber and the customer. But but we find out that it's not a good character for the k-means clustering, because the customer will scatter all of the stations, and we will get the same result if we apply the k-mean on the stations. So it can work. Okay, that's it.
Okay, for the maintenance part, so if we track a kiosk station in the New York City, then we'll find that there is three main parts of each station. First is the dock facility, which is let you to borrow and return the city bike. It can lend you swipe card. And second is the city bike available in the each station, and the dock available in the each station, which can let you return the bikes. And there are already many apps that can show you the updated bike available bikes and available docks of each station. So here I based on the Java with Eclipse and with Maven to make the maintenance part of the city bike system. First, we will get the facility maintenance, and I will extract the each station name of the city bike system, and for every record when one specific station's bike was borrowed out or returned, and I will calculating the swiping times of the each borrowing facilities, and every facility have its average usage age according to its production, so we can make an estimate of its using condition when its swiping time is getting larger. So here is the output result of the facility maintenance. So the three columns of the output is the station name and the swiping times and the current condition of the facilities. And for the city bike maintenance, I will calculate the riding times in minutes for each bike ID. And you see the output, the three columns is the bike ID, the totally riding times in minutes unite, and the current condition. And for city bike regulation, here I will record every borrow and return record of each station and make the updated available bikes and available docks of each station. If the bikes is exceeded limit or if the station is totally empty, so bike regulation is required. And you can see for the output, the three columns is the station name and the available bikes number and available docks number, which is updated after each record.